All right, how on earth am I going to get caster feet for a 22-year-old shop vac, the parts for which have long since been discontinued? What am I going to do about this? Oh, well, that was easy. Hey, what's going on, everybody? My name is JB. Welcome to the All Things Mechanical YouTube channel. Today we're going to finish up the rigid shop vac project. And the reason that I'm down here in my office is because I've actually already finished the project. I filmed that segment yesterday, but I managed to recreate missing caster feet on my 3D printer. More about that here shortly. But the last couple of weeks have been really busy for me, which is why I haven't posted a follow-up before now. But within the last 2 weeks, my wife and I both have celebrated our 40th birthdays and our 18th wedding anniversary. I also had a death in the family. We lost my Aunt Debbie last week. She passed away from cancer, multiple myeloma, which is a blood cancer that metastasized to her brain, her liver, her kidneys, all within 6 months. She was fine 6 months ago, and now we have lost her. So that has been very difficult. I loved her to death. My mom's situation, amazingly, guys, I know if you go back to the videos I posted in January of 2022, we did not know how long we had with my mother. She was diagnosed with stage 3C cholangiocarcinoma, which is a brutal form of liver cancer with a 3% survival rate. I am astounded and ecstatic to report to you guys that my mom is part of that 3%. She has not had any chemo, radiation, or other therapies since November of last year because the treatment was making her so ill, she begged her oncologist to give her a break for the holidays so she didn't feel like crap. And he gave her that 3 months off. She had some tests back in January, no cancer. She had another round of tests a couple of weeks ago, still no cancer. She is a walking miracle. Not only is she a total badass for beating cancer twice now, but she is just, there's no other explanation than God's grace coming down and guiding her and all of us through this. So I could not be more happy that I have more time with my mom. Actually, a few months ago, my mom told me that she was getting into painting again. She was trying to get her creative juices flowing again and trying to occupy some of her time with some creative outlets. So I said, Mom, for my birthday this year, the only thing I want you to do is paint me something. Anything you want. I don't care what it is, surprise me, but paint me something that you make with your own two hands that I can keep forever. Because at that time, I didn't know how much longer I had with my mom. I didn't know what the scans were going to tell us. I didn't know what her prognosis was. And I wanted something to always have that she made just for me. And this painting on the wall hanging behind me is the painting that she painted for me. It is of an acoustic guitar, and it is one of the most prized possessions I have ever or will ever own. She painted this thing for me, and I'll roll in a close-up picture of it here in a second. But she painted it for me, and then she went down to Findlay, Ohio, where my Aunt Cindy's frame shop is. My Aunt Cindy and my Uncle Dutch just bought Reich's Frame Shop in Findlay, Ohio, which has been around since 1888. The owners were going to let the shop go out of business and close down, but my aunt and uncle swooped in and saved it, and they've been running it ever since for about 3 or 4 years now. And my Aunt Cindy and my mom picked this beautiful frame, and my Aunt Cindy encapsulated the entire painting in museum-grade UV protective glass, completely sealed back and front, and it is perfect. And I cannot thank them enough for putting the time, effort, and love into that for me. It is seriously one of the things that I will cherish for the rest of my life. So I don't want to belabor the point. I've just been busy. I've had some stuff going on. I just want to give you a little bit of an update because I know a lot of you, bless you guys, for reaching out to me and asking how my mom's doing. Everyone who's done that, you guys seriously mean the world to me for caring that much to basically ask a total stranger how my mom is doing with her cancer battle. And as of right now, she is cancer-free. There's no guarantees that is going to remain cancer-free. She's going to have to be tested multiple times every year because this is very aggressive cancer, and we're pretty confident that at some point it's going to come back. But for right now, she's cancer-free, and we have more time, and that's all I could possibly ask for. So enough about that. Let's get on to the shop vac. Let's get that finished up. I'll bring you back shortly, and we'll go over the printer and what I've done to it. Well, hey everybody, welcome to All Things Mechanical. My name is JB, and today we are going to finish up this little rigid shop vac project. If you remember from my last video, we got this guy for free. It was completely disgusting. It was covered in filth. muck, sawdust, drywall dust. The float and cage inside were completely seized up. Anyway, we got all that squared away and it works perfectly. For a freebie that we got off of Facebook Marketplace, I'm really, really happy with this vacuum. The one issue that it still had, though, is that it only had one of these caster feet that came with it. It didn't have any actual casters, and it only had one out of the 4 mounts. And I alluded to this in the end of the last video, but I did get a 3D printer. And I've been messing with it for about the last month now. And I am not an expert by any stretch, so I did not design these myself. I actually found the STL file on Thingiverse for a Craftsman vacuum. But I looked at the pictures for this file on Thingiverse, and he had a Craftsman vacuum, and the bottom was almost identical with this kind of ribbed surface down here. So I decided to do a test print. I downloaded the file, it was free. I did a test print out of PLA, which is polylactic acid, which is about the cheapest filament you can get. Doesn't have very good impact resistance, but it's great for prototyping because it's so cheap. So I made one and it actually fit, and it was almost identical. The only issue that I had with it was that these little dovetails that engage on the inside of the bottom of the vacuum were just slightly too wide. So all I did was take my belt sander right here and just knock down the width of those dovetails a little bit. I'm still probably going to need to hammer them in place because I actually emailed the guy that created the file, and he said he did have to tap them in with a rubber mallet. So I'll get my mallet out and we'll do the same thing. There is a screw hole right here. Rather than having these little ridges or splines, I guess, on the OEM version, these actually are split. It's a split design, and it's designed to have a screw go up in here to wedge that apart to lock it in place. But I'm not going to do that. These things fit so tightly in there that I don't think I'm ever going to have to worry about them coming out on their own. I can still remove them, but they're not going to just walk away, especially with the weight of the vacuum kind of holding them in place. I also went on Rigid's website, and I ordered 4 brand new casters for $4.25 each, which is probably a little bit much considering these are 90% plastic with the exception of the metal barb that sticks up to engage. But these things are a perfect fit. I wanted to order them directly from Rigid just to make sure I got the right ones. The only issue that we still have here, I don't remember, I tested this already on one of these. The hole diameter for these is just a little bit too small in here. So I have, I believe, a 19/64 drill bit. Yeah, 19/64, that's about the equivalent diameter. And I got it marked with a piece of blue tape. And I already drilled this one out. But we're going to drill out the remaining 2. I think I said that I was going to make all 4 of these things in the last video, but I ended up only making 3. There's just no need to waste the material. I mentioned that the test piece that I did was made out of PLA. The actual pieces that we're using here, these are printed out of PETG, which is a much different compound. It has a lot more shock and vibration resistance and temperature stability. PLA will actually start deforming if it's left out in direct sunlight. That's how weak it is. It's great. It's a great product, and it's great for doing all kinds of stuff with 3D printing. But for something that's going to be used kind of hard, like a vacuum foot, you want to make it out of either ABS or PETG. I chose the PETG because ABS, while it is more durable, it is very toxic to print without a fume ventilation system. And my printer is located in my office in the basement. My kids' bedrooms are right next to my office. It's just too much to risk. For right now, PETG is more than good enough for our needs here. So I need to drill out the holes for the other 2 of these things, get the casters mounted. We'll go ahead and flip the vacuum over and get the actual caster mounts and casters mounted onto the vacuum. And then we'll be done officially with the Rigid Shop Vac, and it'll be back to 100% condition. So I think with shipping from Rigid and everything, I'm maybe into this thing $60 now. I'm just going to keep the hose that came with it. It works fine. I've used it a couple times since then. No reason to reinvent the wheel until that actually breaks. But yeah, that's this was a really lucky find. I didn't have to design anything because I've been trying to learn Fusion 360 and it is a nightmare. It is very, very complex and not very intuitive. So that's going to be a work in progress thing. But we're going to finish up the vacuum, and then I will take you guys down to the office and I'll show you the printer setup, what I've got, what I'm doing with it, and why I chose what I chose. But anyway, let's go ahead and get these other 2 remaining caster feet drilled out. We'll get them installed on the vacuum, pop these casters in, and then we'll be done with this thing. So yeah, let's get to it. And again, I got this marked with a piece of tape so I don't drill through the storage pocket here. We don't want to have any extra holes in this if we can avoid it. All right, I've got all the casters installed here. I just drove them in as far as I could by hand and then popped the actual wheel off, and then just went over to my vise right there and just tapped that shaft all the way up until it was flush, because you don't want this thing to be cattywampus when it's sitting on the ground. So go ahead and remove the lid off the vacuum here. Good, I already emptied it. Wasn't that much in it to begin with. Flip this guy over. We'll just set these things in place. And I can't get over how good of a fit. This is the factory one. I cannot get over how good these things fit for a 3D printed part that I found on the internet. I didn't have to pay a dime for the files. Pretty impressive. And filing down that dovetail makes them fit even better. So that's it's a nice snug fit, but it's not too tight. Let me grab my mallet. Beautiful. Back over here. Oh, that sits beautifully with no flexing. Look at that, guys. 3D printed caster feet. Do they fit perfectly? No, they don't. But dang, I mean, the files were free, and now I got a completely functional vacuum. This is incredible. I mean, do they fit perfectly? For my purposes, yes. I mean, there's obviously some gaps there. I don't care about that. Considering these are made for a completely different vacuum. Actually, it was probably made by Emerson. I don't know if Emerson made Craftsman's vacuums or not, but it looked identical in the pictures. It just happens to fit perfectly. So there we go, guys. Look at that. Everything about this thing is back to 100%. Incredible. Love it. 3D printer's already paying for itself. I gotta get this lid on straight, though. I can get it on the way. Anyway, go ahead and wrap this part of the project up. The vacuum is done. Now, I'm gonna take you guys downstairs and I'll show you what I'm working with as far as my 3D printer. There we go. Awesome. Love this thing. All right, everybody. Welcome to my ever messy desk. But this is my 3D printing setup. As you can see, it's printing stuff right now. I am actually re-recording this little segment because I just got this little wireless lav mic. It was about 25 bucks on Amazon. I'm pretty sure the audio quality is going to be complete garbage, but hopefully it will eliminate some of the background noise and fan noise and stuff from the printer and everything. It just comes with this thing, a charging cable, and a little dongle that plugs right into the USB-C port on my phone and kind of takes over audio. So it's really simple, just it's not, you know, it's cheap, so it probably doesn't sound that great, but we're gonna give it a shot here for this and just see what happens. Anyway, what we're looking at here as far as my 3D printer goes, this is a Creality Ender 3 S1 Pro. Now, why did I choose this printer over all the other myriad of options that are out there? Well, it's pretty simple, money. I'm not a wealthy guy, okay? Even with the new job, even with my wife making more money than me still, I'm not a wealthy person, and I didn't want to spend thousands and thousands of dollars on a 3D printer because I don't know what the hell I'm doing, all right? I'm a total rank amateur when it comes to 3D printing. Now, my sons know quite a bit about it compared to me because they've been doing it, my oldest son especially, for the last few years. He had a Prusa Mark III at one point. He had a Creality Ender 2, I think, at one point. He since sold all of his 3D printing stuff. First of all, Creality, say what you want about Creality. They're not the highest end printers in the world. They're prone to having issues, and if something breaks, you're better off just trying to fix it yourself because you're probably not going to get a whole lot of support from them. Creality is a Chinese company. Most of the low-end printers that you see on the market are knockoffs of Creality or Creality itself. I mean, they've kind of set the market for entry-level printers. That's why I ended up getting this one. That being said, this is Creality's flagship printer, and they have done an amazing job of making this a really, really slick little setup for people who are new to printing. Now, why did I choose this one over a different Creality model or a different Creality series, like the CR series? Well, it's pretty simple. A, cost. B, features. This printer is normally about $500 by itself. Like $489 is what it goes for when it's not on sale. However, Creality has been around for 9 years now, and they just celebrated their 9-year anniversary. And this thing was on sale at Creality3Dofficial.com for, I believe, $379. So it's already over $100 off compared to what the retail thing was. Now you might notice this guy up here. This is the Creality Sonic Pad tablet. That's normally an additional $160 by itself. But they had a bundle package going where if you got the S1 Pro and you also got the Sonic Pad with it, they would give you an additional 10% off on top of the already smoking deal that you could get the S1 Pro for. So out the door, shipped to my house, this thing cost me less than what the Creality Ender 3 S1 Pro would normally cost when it's not on sale. I got this entire package for $486 shipped to my house. No shipping fees, no tax, because they ship from out of state. But that's it. So first of all, it was a really good deal. Second of all, why my eye kind of got attracted to the S1 Pro model is for a couple of different reasons. Now, I've made some modifications to this, which I'll go over in a second, but putting all of that aside, I just want to talk about the basic features of the printer before we get too in-depth with this. First and foremost, you can see right here, you have a top-mounted spool for your filament. You have a filament runout sensor, which is kind of hiding behind the Sonic Pad over here. So if you run out of filament in the middle of a print, it will pause the print instead of just continuing with nothing coming out of the extruder. And it will alert you and let you know that you need to reload your filament. You have this nice LED light bar built into the top here, which illuminates the whole print bed, which is really nice. Now I have a secondary lamp over here just to have a little bit more illumination for more intricate stuff, so I can make sure it's laying down the filament the way I want it to. And you can buy these light bars and add them to, I think, any of the Creality Ender printers if you want. Ender 3 printers anyway, with the same gantry size. But another thing I really like about this is that it has dual Z-axis lead screws right here. There's a lead screw and a motor on both sides of the gantry. So rather than having one motor that drives 2 lead screws via a belt link, you have 2 individual motors, but you still have a link belt at the top here that makes sure your Z-axis is always in sync. So those motors can never get wonky and have your gantry tilt or whatever because one side's higher than the other. So I think that's a really nice feature. That's pretty cool. Second thing I really like about this is the direct drive extruder. This comes with the Sprite extruder. And what that basically means is that it's all self-contained. Your hot end, your extruder, everything is right here. You just drop the filament right into the top here, and it's an all-metal gear drive system, and it pulls the filament right in. Another thing I really like about the Sprite extruder, it's an all-metal hot end, which means on most Bowden tube style setups that don't have an all-metal hot end, you have a little piece of PTFE tubing right before your heat break. And over time, you know, especially if you're printing higher temperature filaments like PETG or ABS or what have you, that PTFE tube will actually start melting and deforming a little bit because it can only handle so many heat cycles before it degrades. You don't have to worry about any of that with the Sprite extruder. It's direct drive, everything in there is metal, and it works really, really well. I've made some really high quality prints with this thing, and I only have a month of time on it. I mean, it's, if that, not even quite a month yet. So I've been really, really happy with the direct drive setup. It's really slick. Another thing I like, they have this neat little tool tray built into the front here. Now I did 3D print a little tray insert that goes in this thing that's printed out of PLA. I don't know if I'll be able to get it out of there or not. But that just drops in this just drops in the drawer. But it's basically just a divider. So you can put your tools in there, you put your Allen wrenches and regular open-end wrenches and stuff in here. I got other little trays for hardware and whatnot. And then right here in the front, there's a little cutout for 5 different nozzles. I did get a set of steel nozzles on Amazon for this thing, just because they're a little bit more wear resistant than brass. And I do intend on printing some of this kind of stuff out of carbon reinforced nylon, which is a really, really abrasive filament. So I wanted to have some steel nozzles. I'm still trying to find either a ruby or tungsten carbide nozzle, but they're all either really expensive or out of stock right now. But we'll see how far I get with the steel nozzles first, and then we'll worry about the fancy stuff later. So yeah, moving on. There is a ball bearing filament spool that mounts to the top here. Assembly is super easy. I mean, basically the whole thing is nearly assembled right out of the box. All you have to do is bolt on the gantry and plug some stuff in, and then bolt the extruder onto the X-axis, and that's pretty much it. You just plug it in and go. Now, usually the Ender 3 S1 Pro comes with this guy. This is a touch screen that mounts typically right here onto the side of the printer, and kind of it's at an upward angle so you can see it. Because I'm running the Sonic Pad, you don't need this anymore. Even if it's plugged in, the only thing it will do is light up a couple of dots on here. That's it. It's completely non-functional. It's an unnecessary piece of hardware at this point. So I've just taken it off completely to free up some desk space, and I have the Sonic pad mounted up on top of the gantry with a mount that I 3D printed. I downloaded the STL files for that off of, I believe, Thingiverse or Cult 3D, I'm not sure what, but it works perfectly. Really, really good. Didn't take too long to print. I mean, it's a big print, a tall print, but it's broken up into 2 halves. It just snaps onto the top of the gantry, and then the Sonic pad, you just take the normal legs off of the Sonic pad, because typically, kind of like a phone case, this is like a little kickstand. It folds out and kind of allows you to set the Sonic pad at an angle up on your desk or whatever, so it stands up by itself. All you do is unbolt these and bolt the mounts on where these feet would go. Now, the only thing that I had to make a slight modification to on the new mount that I printed is that the guy who designed it, I don't know if you can see that or not, the guy who designed it had both ends of this completely round, whereas on the feet for the Sonic pad, there's this little cutaway here with a rubber pad on it, so this thing can sit flat on the on whatever surface you're setting it on. I had to take the mounts and go to my belt sander and chop this off at the same angle. I actually use these as a template just to get it to fit in there properly so the bolt holes lined up. And once I did that, it was perfect. It bolted right in. So not a big deal there. The main reason I got the S1 Pro, not counting all these other little fancy side features, is the fact that the printer bed itself will heat up to 110 degrees Celsius, I believe, and the nozzle will heat up to 300 degrees Celsius. So that means you can print just about any filament you want. There's very few, with the exception of a couple of like really random specialty filaments, you can pretty much do whatever you want. You can print ABS, you can print PETG, you can print TPU, you can print PLA, you can print PLA+. It'll run just about anything successfully on this printer because of how hot this thing gets. So that's a big deal. I wanted to kind of get a higher end entry-level printer, if that makes sense, because I wanted to kind of future-proof it a little bit for my own needs, as I didn't know what I was going to be doing with it. I liked having the ability to print ABS, even though I'm not going to do it down here. This thing is in my office, in the basement, right next to my teenagers' bedrooms, and printing ABS absolutely 100% requires some kind of fume extraction setup, because the fumes that ABS will put off as it's being melted and extruded are highly toxic. And that is way too much of a risk, especially down here in the basement with my kids' bedrooms right there. And so I don't want to do that. Nice thing is I have this gigantic egress window right here, so I could probably get some kind of fume extraction hose or whatever and crack the window and get one of those little vent tube things that kind of fits in between the window and the sill. You can close the window on and seal it. Problem is the window opens on this side, not over here. So I don't know how well that's going to work, but I'm not printing ABS right now, so I'll cross that bridge when I come to it. But that's the primary reason I got this thing, is for the higher, hot end temperatures and the higher bed temperatures that this thing's capable of. It just opens up a lot of options for you if you decide you want to print different types of materials. Now, let me talk about the Sonic pad for a second. That thing is amazing. It's amazing, all right? The Sonic pad, if you're not familiar with it, it's basically a tablet made by Creality to run their printers with Clipper firmware instead of Marlin firmware. Most of the printers out there in the ether right now, probably 95% of them, run on Marlin. And Marlin is an okay firmware, it's capable, but Clipper is on a whole nother level. And I haven't even scratched the surface of what it's capable of yet. But the advantages that you have with running Clipper is that the tablet comes with these little guys, these little G sensors or accelerometers. It also comes with the cable. And it also comes with the STL files baked into the Sonic pad for you to print a mount to attach this thing to the extruder and run resonance testing. Now, what resonance testing is, essentially, is that you bolt this onto the extruder, you bolt your accelerometer onto it, and then you plug this ribbon cable in, which plugs into the serial port on the back of the Sonic pad. And when you tell it to begin the test, it will make the motors vibrate at all kinds of different frequencies. And the software in Clipper will actually, depending on what surface you have the printer set on, how it's angled, how stable it is, whatever vibrations that thing picks up inside the accelerometer and G sensor, Clipper will go in as you're printing and counteract those vibrations by making the motors vibrate at the opposite frequency to cancel it out. I don't know how that works. That's way too fancy for my brain to comprehend. All I know is that it works really, really well. In addition to that, you can also do what's called pressure advance tuning. you can download a tuning, what's called a tuning tower STL, and then you paste some commands into the G code on the Sonic pad, and it enters into a test mode, and it will print this basically big square at different extrusion rates as it gets higher and higher and higher up. And basically you want to, there's really good videos about that. Z over at ZMade put out a really, really great video about how all that works. So I'll link that video in the description, because he's a police officer as well, and I'm a former cop, so immediately when I found that out, I'm like, all right, this guy's not too bad. But he puts out some really, really good content regarding Clipper, this exact printer, and the Sonic pad. He's running the exact same setup I am, and he's been a really, really great source of information for me. So again, the channel's name is ZMade. I will go ahead and link to his channel in the description. Go over and check him out, because he's going to explain all this far better than I can. He's actually I believe an engineer, and has been doing 3D printing since like 2010. So he's got far more experience than I do in this whole realm. So anyway, go check out ZMade if you want more information on that. But you can basically set your pressure advance tuning and your resonance testing, and once you get those things knocked out, you can really juice up how fast this thing prints, like significantly faster. I'm going to give you an example. After everything was tuned in, I printed this baby Groot at 120 millimeters a second, and you can't even see the layer lines. Now, if you're not familiar with 3D printing, that's pretty freaking fast, especially for a design this complex and this detailed. I mean, that is pretty freaking nuts. 120 millimeters a second, 150 millimeters a second for the support speeds, because you don't really care what the supports look like. Supports are basically other objects that you bake into the STL to support little dangly bits like fingers and whatnot, because obviously the printer, if it doesn't have anything below where you're trying to print, it's just going to goop down a bunch of filament onto the heat bed, because there's nothing there to support the shape you're trying to create. So you have to create supports in order to get that going. But just to give you an example of what you can do after tweaking some stuff, this is the first one that I tried. I don't know how well it's going to show up on the camera, but there is a lot of Z-rigging going all around this thing. I did color the eyeballs in myself. That's didn't come with the file. A little bit less on this one, although it's still pretty pronounced. I probably should get a flashlight or something, or some way for you to see that. But yeah, you can kind of see it there. See all the striping? So I went from that to this, because I got the supports wrong, so his arm broke off. And then I went to this, which looks fine, it's smaller. But the hand broke off, and I was trying to get the supports out. And then I finally ended up with perfection. I scaled everything up a little bit, changed the supports, and that was, again, printed at 120 millimeters a second. And you can't even really see the layer lines. 0.16 layer height, 120 millimeters a second. So I'm going to be painting this guy and finishing it off. I'm probably sending it out to a friend of mine. So this printer is very, very capable. It's a really, really nice setup. Say what you want about Creality, but I think they've really done a great job with this. Now, how I have my Sonic pad set up, again, I told you I took off the main control board that came with the printer, the touchscreen. So you have to link the Sonic pad to the printer through this USB-C port in the front. So I got a 90-degree USB-C cable, ran that down on the inside of the foot down here underneath the printer, the little rubber foot, came back around behind the gantry here, and then I got a full-size USB adapter that comes out and immediately makes a 90-degree back toward the back of the gantry, and then I plug the other end of that USB-C cable into that. That way I don't have anything sticking way off to the side. So it's really nice and kind of tucked in back there, and it's working out great. I haven't had a single issue with it. The one thing I will say, though, about the cable that comes with the Sonic pad, it is junk. This thing is garbage. This is what they give you to basically to go in the front here, where I have this aftermarket cable. This is the one that came with the printer. I was pulling my hair out for about 20 minutes because I could not for the life of me figure out why the Sonic pad was not communicating with the printer. Turns out I had a bad cable. I went upstairs and got a Samsung USB-C to USB cable, and it worked just fine. So once I figured out that that was a problem, that's when I ordered that 90-degree stuff and the adapters and whatnot, just to kind of finalize my setup and get it cleaned up a little bit. But if you have problems with the Sonic pad not communicating with your printer, 9 times out of 10 it's going to be this crappy cable that comes with it. So, you know, again, made in China. What can you do? Sometimes you get a good one, sometimes you don't. Anyway, so as far as modifications go, what have I done to this thing? Well, I've made a few tweaks. First and foremost, bed leveling. you have to manually level the bed yourself. This does have a CR touch probe, so it will go and do, I think it's like a 24-point bed level, but you have to go in here and level everything out yourself manually first, or it's going to be too much for the software to compensate. You have to go in there and manually level it first using a piece of paper and these wheels on all 4 corners. I have replaced the black plastic wheels that come on this thing with these nice blue anodized aluminum ones, and I've taken the springs that go between the bed and the adjuster wheels and replaced those with black silicone bumpers, basically. So instead of having a spring, it's a silicone cylinder that compresses. And the reason I did that is because the silicone is highly heat resistant and it's also very, very vibration resistant. So once you set those and get some tension on them, you get the bed level and you don't really have to mess with it very much after that point. Now, I did re-level it this morning because I noticed that this one loosened up on its own, and the bed was tilted quite a bit, so it was laying down the brim just fine, but when it got to the right-hand side, it was really smearing it into the glass. So I just redid my bed level, and now it's perfect and it's fine. So it happens occasionally, but that's the first time in 3 weeks that I've had to even touch my bed level. And I've made a lot of prints on this thing in that time, so that's pretty good. So another couple little odds and ends that I've done. I printed out, just to see what I could do, I printed out these little knurled knobs for the belt adjustment wheels. There's one here and there's one here. You can probably see Flexible Rex right here. This is a Tyrannosaurus Flex, I think it's called. My daughter saw this on Thingiverse and she wanted me to make one for her. So I have 2 of the ones that got goofed up. This is when I was first starting out. I didn't have the settings for the PLA right. And you can obviously see it printed like this, and the PLA warped and curled up really bad on the feet on this one and on this other green one. So I just kind of put the rejects over here on the printer gantry, and they just kind of watch the prints as they're happening. So I've got the knobs, I've got the Flexi Rexes. I also have some different cable holders. You can't really see, but I have a different cable holder here, and I also have a different cable holder right here that kind of keeps this up and supported a little bit more. As it comes in stock form, this whole ribbon cable just kind of hangs down and puts a lot of stress on these little wires that go to the motors and everything, so I didn't like that. So I didn't design any of this stuff. These are all STLs that I found on Thingiverse for free, and they've made a big difference in how this thing kind of loops around and everything. And before I added these 2, this ribbon cable had a tendency to fold down right behind the extruder here and actually rest on the printer bed. And when it got really, really hot, I didn't like that. It's a recipe for disaster in my brain. So I squared that away and didn't have any other issues past that. Now, obviously, if you know anything about the Sprite extruder or Creality printers in general, you're going to see these 2 gigantic 5015 computer fans on here. Clearly, that's not stock. What comes stock on this thing is your part cooler fan right here, which I believe is it's a 4024, so a little tiny guy. And the hot end heatsink fan is only a 3024, this little guy. That's what cools the whole hot end. So because I was having issues with PLA warping, especially when you try to go faster, I downloaded the STLs for this stuff. I did pay for the STLs for this one, I believe. But those STLs basically replace all of this stuff. This is where the CR touch probe mounts right here. So right here. It prints in 2 pieces, but it replaces this part and this back plate. So you got to take the outside of the extruder apart, and basically these new fans just bolt right in. I just have some, I believe it's M2 hardware. I got this whole hardware kit off of Amazon. This 820-piece metric hardware kit for all these little machine screws and nuts and washers and whatnot. So that's really helpful. And that was not very much money. I think that was like 19 bucks, I think, for the whole kit. But I used that to kind of put all this together and bolt it together. And that has been a game changer. The only other thing you have to do to get those fans to work is that they come with these gigantic JST connectors on them. These are they're actually not gigantic, they're actually quite small when you hold them in your hand, but the Creality connectors are micro JST. So, teeny tiny. That's what we're dealing with here. These are the ones that you need to be able to plug those fans into the motherboard on the extruder. So I just cut these off of the new fans, and I ordered another pack of these micro JST connectors, which is like 30 pairs for less than 10 bucks. So I don't need all these, but if I ever need micro JST connectors again, there you go. I got a whole bunch of those for less than 10 bucks. And the fans themselves, 4 of them, I still have 2 left over. 4 of these things for, I think, less than $11 on Amazon. And these are the Winson brushless DC fans, 24 volt with hydraulic bearings. So they move a lot of air and they are very quiet compared to the stock fans. These little fans that were on there in stock form, just going full tilt, going just trying to throw out as much air as they could. And they make a lot of noise without putting out a lot of air. So this fan is always on 100% when the extruder is turned on. There's no way to adjust that in the settings. This fan at 50% puts out probably twice as much airflow as the stock part cooling fan at half the noise level. It puts out a lot of air. So that was a really solid upgrade, and that's the reason why I can get perfect prints like this at 120 millimeters a second. This is made out of matte PLA by Polymaker. It's fantastic PLA, by the way. But those fans combined with the Clipper software and the tweaks and tuning stuff that I did with that, that's the reason this works out so well. So out of the box, this is a fantastic printer, but if you want to put just a little bit of time, effort, and maybe some money into it, you can really tune this thing up and make it work really, really well. So that's my printing setup. I'm extraordinarily happy with it, and I, you know, as a total novice, I've been pretty pleased. I mean, if you can knock out stuff like this with only a couple of weeks under your belt, really super complex prints, that's a pretty good setup. So I am more than pleased with it. But that's it for now, guys. If you have any questions about this, or if you want to see more content like this on the channel, please let me know, because there's a whole bunch of stuff that I want to print still, and there's a whole lot of things that I want to get into, and I'm just looking for ways that I can continue to put out content for you guys on a semi-regular basis. I haven't really been able to do that as of late, but I'm hoping now with all these little avenues, the musical stuff, the instrument stuff, the guitar stuff, repairs and whatnot, the 3D printing, plus the stuff that I have out in the garage, you know, and regular maintenance and things on my vehicles, I'm hoping I can come up with some things to keep you guys entertained. So please let me know in the comments what you want to see. If you want to subscribe to the channel, I would really, really appreciate it, because that helps everything that I do. It puts me further up in the YouTube algorithm, and it just helps keep my channel growing. And that's the biggest thing, because without interactions from you guys, without those likes and without those subscribers and without the shares, YouTube forgets about me and I get buried. And it's happened to me a few times now, and most of that's my fault because I haven't been uploading very much lately. But again, I'm trying to get back on track with putting out stuff on a regular basis. So again, like this video, share it if you think someone else would enjoy it, subscribe to the channel if you want to see more, and get out there and start doing something. Either fix something, get your hands dirty, get into 3D printing. I mean, you can get 3D printers for 150 bucks if you want to try it out. It's not difficult. You don't have to spend 500 bucks. You don't have to spend 1,000 bucks. You don't have to spend 6,000 bucks. The opportunities are out there if this kind of stuff interests you. But in the meantime, again, go check out Z over at ZMade. It's a great channel, really, really good guy, great content. And he will go into a lot more detail on this printer and Clipper and the Sonic Pad itself with far more accuracy than I can, because I just don't know enough about it yet. But anyway, that's all I got for you this time, guys. Thank you very much for watching. I know this video got kind of long, but I appreciate each and every one of you guys very much. Thank you for your support. Thank you for sticking with me, and thank you for watching. You guys have a great day. Be safe, have fun, get your hands dirty, go make something, go fix something. We'll catch you on the next one. See ya.